Okay, the other thing, we're just waiting for confirmation from Mr. Bobeta, but probably June 10th, which is a Saturday, we'll be running a 30-1 review session here in the school. So it'll just be a chance for some extra review. I think we've got 6 classes left for you guys. So, we're going to get a chance to go through um, a lot of stuff, but it'll just be a chance for some extra review. So it'll be during the day on the Saturday, probably somewhere starting around 8:30 or 9. Don't know for sure. Um, and I think the plan is, although this is yet to be confirmed, is that they will be feeding you guys lunch as well, so you don't have to um, leave the school. It just gives more time to get stuff done. So again, this is all still being confirmed, but that's the hope that it all comes together. And yeah, I mean, obviously, it's totally up to you guys if you want to attend, but it'll be the 10th of June, most likely, because your exam is on the 16th. Okay, and remember the 9th, week from tomorrow, is the last day to hand in any missed assignments. So you guys have had lots of notice on that, so there'll be no extensions, no exceptions. Don't leave things till the end, because if something happens the night before and you don't get a chance to finish some of them, too bad, so sad. Okay, so don't leave it to the end. So let's start reviewing the unit we just finished on equations and functions, chapters 9, 10, and 11. So first question says, given those functions, you're asked to sketch the graph of h and also state domain and range. And for the first one, h at x is found by adding f and g together. So that's what we'll start with. We'll just simply add the functions together and simplify by collecting any like terms. Negative x plus 2x is x. 7 plus 1 is 8. So when we're graphing it, I mean, this is a line. That's a line that has a y-intercept of plus 8, which I think is at the top of this grid. I know that's not the best grid there, but and a slope of 1, which means you're going to rise 1 and run 1, or rise -1 and run -1. That works as well. Rising -1 and running -1. That will give us the line. And when we're talking about domain and range, you always have to remember to look at the original equations, which are both linear, so there are no restrictions on what x or y can be or can't be. So our domain, we could say, goes from -infinity to positive, and same as the range. So I'm using interval notation here because that is generally the easiest way. Say that again. So you know how when you're proving like trig identities, you have to write a statement at the end to say left side equals right side, or you could use that tombstone, which is the little box. So with, anything else like that you need to know for it? Is that like any other things that for solving equations? No, like just in general, like things that will be different. I don't think so. I mean, when we did trig equations, we did that, right? So it's not anything. I mean, it would have been a new from previous math courses, but we did that when we did proving identities. So for question B, h in this case is found by multiplying the two functions together. So that'll give us 14x plus 7 minus 2x squared minus x, or negative 2x squared plus 13x plus 7, which is a quadratic that opens downwards. And in this case, I would probably use the graphing calculator to help us sketch. And you don't even have to put the final equation in the calculator. You could put the equation in factored form, and it would still give you the correct graph. You could put in brackets 3 minus x, and then in another set of brackets 2x plus 1. It will do it. I'll use zoom 0 to set our windows so the calculator picks the windows, because there's a couple key things that we want to find here. One of them might be the x-intercepts. So second function trace, number 2, which is 0. My left boundary for the first one, and then my right boundary. So it looks like negative 0.5, which, I mean, if you look at the original statement, it's in factor form already. So because 2x plus 1 is a factor, negative 1/2 would be an x-intercept. The zeros of the equation give you the x-intercepts, or the values of x that make y equal 0. Because we started with factor form, then we can see what the x-intercepts are. The first one being negative 1/2, the second one being positive 3, because of the factor 3 minus x, make that equal to 0. But what we can use the graphing calculator for is to find out where the maximum point, where the vertex is. Second function trace, number 4 for maximum. My left boundary is good there. I'll put my right boundary at 9. And the maximum is at 3.25, comma 28.125. So it's quite high to help us do our sketch. But what that's really valuable for, models are there.
No shredding.
No, thank you.
Okay, that's all right.
So what the calculator is really helpful for is also to state our range. Our domain will be all real numbers, goes left and right forever. But again, if we go to our calculator, the maximum value is 28.125, and the graph goes downwards from that. So we can go from negative infinity to 21.125. And in this case, the 21.125 will have a square bracket on it. That is a point on the graph. It is included. All right, question C. G over f at x is g at x over f at x. So that'll be 2x plus 1 over 7 minus x. And here we have a restriction, x cannot equal 7. At x equals 7, there will be a vertical asymptote. There will also be a horizontal asymptote. Remember when we did in chapter 9, rational functions? If the degree of top and bottom are the same, then the horizontal asymptote can be found by dividing the coefficients of the highest power terms, which would be 2 over negative 1. Y cannot equal negative 2. That's where the vertical or the horizontal asymptote would be. We learned that if the degree of the top is less than the bottom, then the x-axis will be a horizontal asymptote. If the degrees are the same, then you can divide the coefficients of those highest power terms to get the horizontal asymptote. And finally, we learned that if the degree of the top is greater than the bottom, then in that case, we actually got a slant asymptote. which is not part of the Math 30-1 curriculum, to determine where that slant asymptote is. And when we did it in class, we used our calculators to kind of see where that was. When you're drawing a graph, though, and there's asymptotes, you have to show those asymptotes. It's part of the graph. And we always did that in class. So this will have a vertical asymptote at x equals 7, which is right here. A horizontal asymptote at y equals -2, which is right there. There are no points of discontinuity for this one. But if there was, you have to show that on your graph as well. You have to show the point of discontinuity. So when we go through the exam you guys just wrote, you'll see there was a question on the written response where you had to do a sketch that had a point of discontinuity. Some of you lost a half a mark because you didn't show that. And some of you lost a half a mark because you didn't show your asymptotes. It's part of the graph. You have to show it. And then you can use your calculator, or you can just choose a value of x greater than 7 to show that when x is greater than 7, y is less than -2, which means that the graph is down in this lower right-hand region as well as in the upper left-hand region. And so the domain. I'm going to use set notation in this case, and I could use interval. It just have to be done in 2 parts. All values of x such that x cannot equal 7, but all other real numbers are possible. The only restriction we have on x is that it can't equal 7. Our range, all values of y such that y cannot equal -2. Otherwise, all other real numbers would work. If you did interval notation, you'd have to do it in 2 parts. For example, for the domain, you'd have to say from -infinity to 7, and then from 7 to +infinity. Because you divide +2 by -1. 7 minus x means the x is -1x. All right, and then for question D, h is g at f at x. So that's an embedded function. F is plugged into g. So wherever we see the variable in g, which is after the 2, we replace it with x. But the rest of g remains unchanged. That +1 on the end. So that'll give you 14 minus 2x plus 1, or -2x plus 15. So that's a line that would have a y-intercept of +15 and a slope of -2. Don't really have room on our grid for a y-intercept of 15, but we can generate a table of values. For example, we can find out what the x-intercept is by letting y equal 0. So that would bring the 2x over, and let's show that. This is our x-intercept by letting y equal 0. So we could add the 2x to both sides and divide by 2. X equals 7.5. 1, 2, 3, 4, 5, 6, 7.5 is approximately there. We can find a couple other points. For example, let's say when x equals 6, -2 times 6 is -12 plus 15. So that'll be the point 6, 3. So that's there. And h at, let's say, 4. When x is 4, it'll be -2 times 4, -8 plus 15, which is 7. So 1, 2, 3, 4, 5, 6, 7, approximately there. So we can just use a form of table of values to help us draw that. line. Okay? And there's no restrictions on either x or y here. So our domain, and if you chose set notation, you could just say all values of x such that x is an element of real numbers. Remember, if you're using set notation, you must use those squiggly brackets. You must use those squiggly brackets for set notation. Interval notation, it's either round or square brackets, depending on whether those n values are included or not. Number 2, now it says SE beside it, which means this is a standard of excellence question. On the diploma exam, there's a certain number of questions that fall in the standard of excellence category. I forget what the percentage is, somewhere around 15 or 20% if I remember correctly. But so given f at x equals the root of x minus 1 and g at x and h at x, determine k at x, which is HOGOF at x. Now again, you have to remember to do these, you work from the inside out. So I would start by first doing g at f at x, which means that f is embedded into g. So f, which is the root of x minus 1, is put into g. Wherever we have the variable in g, which is the x that's squared, we replace it with f, which is the root of x minus 1. Because the x is squared in g, the root of x minus 1 is squared in g as well. And then g has that plus 3 on the end. When you square a square root, they cancel. You'll get x minus 1 plus 3, which is x plus 2. So that's what g at f at x is. So now we need to do h of that. H of x plus 2. So now x plus 2 will be plugged into the variable on h. But all the other parts of h stay the same. Right? You're multiplying by 2 and then subtracting by 5. So that'll give us 2x plus 4 minus 5, or 2x minus 1. It also asks us to state restrictions on the domain. And to do that, you have to again look at the original equations. And the only part of this that will have restrictions on x is the first one. Because you cannot take the root of a negative number, x minus 1 has to be greater than or equal to 0. You can take the square root of 0, but not a negative number. So x has to be greater than or equal to 1. There's the restrictions on the domain. So it doesn't really ask us to state the domain, it just asks us to state the restrictions. So these are the restrictions. If it's asking us to state the domain, then we choose either interval or set notation and use the proper form. Okay. This next one, again, this is a standard of excellence question. You've got the graphs of f and g. You're asked to graph f at x plus g at x. And remember, that's found by adding the y values. Okay, so maybe it's helpful to set up a table of values to do this. On our graphs, we have x values of 0, 1, 2, 3, and 4. The values for f when x equals 0 is 2, when x equals 1 is 3, when x equals 2 is 4, and the last two have f at x values of 4 as well. For g at x, when x equals 0, we're at 0. When x equals 1, we're at 1. We have the point 2, comma 2, and then 3, comma 1, and 4, comma 0. Because remember, it's the y values that you're adding together. So to get our values for h at x, we simply add the y values together. The x values don't change, but the y values do. Our new y values are found by adding the y values together from the previous functions. So we'll start at 0, 0. We'll go through 1, 4, 2, 6, then 3, 5, and 4, 4. Oh, I'm sorry. 0, 2. There we go. Right, so there's the new graph. Number 4, determine the value of f at 4. So you're going to have to do it twice using the same function. Working from the inside out, we find f at 4 by letting x equal 4. 4 squared is 16, plus 4 is 20 over 2. That gives us 10. And now we have to do it a second time, now letting x equal 10. 10 squared is 100 plus 4. 104 over 8, which is 13. So there's the value of f at 4. Sketch the graph of the following. Determine the following characteristics for each function. We want the domain, the x and y intercepts, and equations of vertical asymptotes. So those are generally found by getting the non-permissive values of the denominator, which involves factoring the denominator. So the factors for that one would be x plus 4, x minus 2. And that tells us that x cannot equal negative 4 or positive 2 because you can't have a denominator of 0. So our vertical asymptotes will be at x equals negative 4 and x equals positive 2. So we can put those there. X equals negative 4 and positive 2. And in this case, because the degree of the top is smaller than the bottom, the x-axis would be a horizontal asymptote as well. We're not asked to state that, but if we're going to graph it, we should have our asymptote there. Our y-intercept will be when x is 0, and a rational function equals 0 when the numerator equals 0. So our y-intercept is where x equals 0, which will give us 0 on top, and 0 divided by anything is 0. This is also where the x-intercept is. The x-intercept is where y is 0, and as I just stated, a rational function equals 0 when the top equals 0. So these are our intercepts. Our x and y intercept is the point 0, 0. And you can use a graphing calculator to help you see what this graph looks like. You can put it in, and it'll look something like this. And this also illustrates that in some cases, a graph will pass through the horizontal asymptote in one point, but approach it at another. Because the other side, the other part of the graph looks like this, where now it's approaching the horizontal asymptote from below, and on this side from above. And you would punch the equation in your calculator to see what it looks like. So there's that one done. For question B, again, in this case, you're going to factor the bottom, which will give us x plus 3 comma x minus 3. And so in this case, the x plus 3's cancel. And you're left with 1 over x minus 3. So in this case, because the x plus 3 canceled, there's going to be a point of discontinuity applied to that. Right? But before we get there, we still have a denominator of x minus 3. So x equals positive 3 will be a vertical asymptote. Once again, the degree of the top is less than the bottom, so the y-axis will be a horizontal asymptote. We have a point of discontinuity at x equals 3. I'm sorry, negative 3, because the x plus 3 canceled. And when you let x equal negative 3 in the equation of our simplified expression, you're going to get a denominator of negative 6. Negative 3 take away 3 is negative 6. So that'll become negative 3 comma negative 1 6. So approximately there. So again, this graph will look something like this. Whoops. Before I do that, this graph will not have an x-intercept because the simplified equation is 1 over x minus 3. You can't make the function equal 0. A rational function only equals 0 when the top equals 0. And you've got 1 over x minus 3. The numerator is a constant. Also, if you look at the original equation, y would equal 0 when x equals negative 3, when the top equals 0. But we already know what happens at negative 3. There's a point of discontinuity there. So there is no x-intercept. But there is a y-intercept. And that's where x is 0. So that'll be 1 over 0 minus 3. Our y-intercept is at the point 0 comma negative 1/3. So we can put that on our graph. Approximately there. So now I can graph it, now that I have that piece. And again, you can use your graphing calculator to confirm that one arm of the graph is in the lower left quadrant and the other is in the upper right. But again, the graph must have your asymptotes. It must have the point of discontinuity for the graph to be complete. And arrows on the ends. So for number 6, it just says, what is the equation of the horizontal asymptote? Because the degree of the top and bottom are the same, we just divide the coefficients. Y equals 3/2. That's the equation of the horizontal asymptote. Number 7, we want to find the points of discontinuity. Point of discontinuity for this. And again, it involves factoring. So we have to factor the top. Now, the fact that we have a denominator of x minus 7 tells us we're going to have a factor of x minus 7, which tells us our other one has to be 2x minus 1, because the last terms have to multiply to get positive 7. The outer product is negative 14x, the inner minus 1x. That gives you the minus 15x in the middle. So now we see that, yes, the x minus 7's cancel, which means we have a point of discontinuity at x equals 7. And to find out what the y value is, we'll let x equals 7 in our simplified expression, which is just 2x minus 1. 2 times 7 is 14, minus 1, 13. So there's your point of discontinuity. So the graph of that function can be expressed in the form ax over x squared plus bx plus c. We need to determine the values of a, b, and c. So the fact that you have vertical asymptotes at -4 and +5, that tells us that factors on the bottom have to be x plus 4 and x minus 5. The vertical asymptotes come from the factors on the bottom. The factors tell you the non-permissive values. The fact that they are still there, they're not going to cancel with anything, comes from the fact that they are vertical asymptotes. Points of discontinuity come from factors that cancel. So, before we multiply the bottoms out, let's find out what A is. This graph clearly shows that the point 2, -1 is on the graph. That means it must satisfy the equation. Y will equal -1 when x equals 2. This is going to allow us to find out what A is. That y equal -1 and x equals 2. That is a point on the graph. It must satisfy the equation. So 2 plus 4 is 6. 2 minus 5 is -3. 6 times -3 is -18. And if we multiply both sides by -18, we'll get positive 18 equaling 2a. So a equals 9. So now we can write our equation. Y equals 9x over, if I multiply out those binomials on the bottom, I'll get x squared minus x minus 20. So the values of A, B, and C. A we know equals 9. Now we know that B is -1 and C is -20. So if there's a question like this, it would have to be on the written response, because for numerical response, you will never get a negative answer for numerical response questions. If you do on the diploma, you've made a mistake. No negative answers for numerical response, because there's no place to bubble in a negative on the scan sheet. Okay? How many arrangements of all the letters of the word reason are there if arrangements must start with the letter S? So this can be done by using the fundamental counting principle. Reason has 6 letters in it, but there is one choice for the first letter. It must be the letter S. And there are 5 remaining letters. They're all different, so there would be 5 factorial ways of arranging them. You could also do this using permutations by going 1 times 5p5. It's a permutation because order matters, right? When you change letters around, it's a different arrangement. Orders matters. So either way, 5 factorial is 120. If all the letters of the word diploma are used, how many different arrangements are possible that we begin and end with an I, O, or A? Begin and end. So the word diploma has 7 letters again. You have 3 choices for the first letter. It's either got to be an I, O, or an A, and that will leave you with 2 choices for the last letter. Again, there are 5 letters left. They are all different. So you multiply by 5 factorial. Thank you. So 3 times 5 factorial times 2 is 720. Josh wants to rent a car. He has narrowed his choice to a sedan, a compact, or an economy car. The colors available are black, red, or white. How many? He may also choose between standard or automatic transmission. What are the total number of options that Josh has? Well, this is just fundamental accounting principle. He has 3 choices for the type of car, 3 choices for the color, and 2 choices for the transmission. Fundamental accounting principle. You could do this using combinations if you wanted, because the order that he chooses, it doesn't matter. It would be 3C1 times 3C1 times 2C1. Still gives you 3 times 3 times 3. So 9 times 2 is 18. A volleyball team made up of 6 players stands in a line facing the camera for a picture. Joan and Emily must be together. How many different arrangements are possible for the picture? So 6 players. But Joan and Emily have to be together. We learned that if items have to stay together, they count as one object to arrange. So the remaining 4 players plus the set that includes Joan and Emily gives us 5 things to arrange. They can be arranged in 5 factorial way. But we also have to multiply by 2 factorial, which represents the number of ways that Joan and Emily can be arranged amongst themselves. 2 factorial is 2. Joan first, Emily second, Emily first, Joan second. The 2 ways that they can be arranged. 5 factorial is 120 times 2, 240 ways. Determine the number of different arrangements using all of the letters of the word accesses. First, if it begins with exactly 2 S's. So there are 1, 2, 3, 4, 5, 6, 7, 8 letters here. So if we put 2 S's at the start, so the way it's worded, it says it has to begin with exactly 2 S's, which means that the next letter cannot be an S. That's what that means. So if we cross off those 2 S's, we'd have 1, 2, 3, 4, 5 choices for the next letter. It just can't be the remaining S. So now we have 5 letters left, and they could be arranged in 5 factorial ways. However, there's some repetition involved here. There are 2 C's and 2 E's that are left. So we're going to have to multiply by 2 factorial and 2 factorial. Our final answer will be 5 times 5 factorial over 2 factorial, 2 factorial. Because there are 2 C's and 2 E's left to arrange. So there's our repetition part. So 5 factorial times 5 on top divided by, and 2 factorial is just 2. So the bottom will be 2 times 2, which is 4. So there's your answer, 150. And incidentally, all of these questions in this package have come off old diploma exams. No, it's a 5. Nope. Because the question says exactly 2 S's, which means the next letter cannot be an S. That 5 is the number of letters that are not S's that you have left to choose from. Part B says, how many different arrangements begin with at least 2 S's, which means 2 S's or 3 S's. Remember, the word or means to add. Also, we already know that there are 150 arrangements that begin with 2 S's. So now we just got to calculate how many different arrangements begin with all 3 S's. So that means that there are 5 letters left, and they could be arranged in 5 factorial ways. But we can't forget about the repetition again, because there are 2 C's and 2 E's. So 5 factorial, which is 120, divided by 4 is 30. So our answer will be 150 plus 30, which is 180. Part C says, explain why the answers in questions A and B are different. There's getting more and more of these on the diploma exam, where you have to do some writing about the question. Why did you have to do it this way? How is it different? So there's a pretty good chance that there's going to be a question on the diploma exam where you have to do something like this, where you have to write something out. So in this case, what makes them different is that in the first scenario, in part A, the third letter cannot be an S. So in part A, the third letter cannot be an S. That's what makes them different. Number 14. A car dealership, the manager wants to line up 10 cars of the same model in the parking lot, but there are 3 red, 2 blue, and 5 green. If all 10 cars are lined up in a row facing forward, determine the number of possible car arrangements if the blues cannot be together. So that would be all possibilities minus the possibilities with blue together. So all possibilities would be 10 factorial over 3 factorial, 2 factorial, 5 factorial. Repetition. There's 10 cars altogether. The division part will be dealing with the repetition. Minus, what about if all the blue cars are together? Well, there are 2 blue cars. They go together as a set. You have the other 8 cars, plus the set that includes the blue cars would be 9 things to arrange. So it'll be 9 factorial over 3 factorial, 2 factorial, 5 factorial. Now you could simplify this, but Let's just figure it out. 10 factorial divided by, in brackets. And 3 factorial is 6 times 2 factorial is 2 times 5 factorial, which is 120. So that gives us 2520 minus, so I can just change the 10 factorial to a 9 factorial. And that's 252. So now we'll subtract those. 2268. Okay. If 14 different types of fruits are available, how many different fruit salads could be made using exactly 5 types of fruit? So Kevin used 14 factorial to solve the problem. Ron suggested 14p5, Marcel 14c9, Jackie thought 5p14, and Stan used 14.5 like that, which means 14c5. And that's on the formula sheet. You didn't really talk about that notation, but that's on the formula sheet. Okay, I think there's a formula sheet at the very start here. No, not on this one. It's on your other ones. On the back? Yeah. Okay. So there it is right there. Right? So that way with the brackets is another way of writing NCR. It's 3 o'clock, everyone. Yep. Because they look the same. It doesn't matter. The questions we've done before, like in the last one where there were 2 different people, when they switch around, they look different. It's different arrangement because they look different. In this case here, the blue cars are identical, the red cars are identical. So switching them around, it doesn't look like a different arrangement. It looks the same. Whereas if you switch 2 people around, unless they're clones, they're going to look different. It is, yeah. That's just counting for the repetition part, not switching them around. 2 different things. Okay, so which ones gave us the correct answer? Well, in this case here, order doesn't matter. So we can eliminate Ron. He's a dumbass. Whoa! Kevin is also a dumbass because Kevin is thinking that all 14 fruits are going to be used. Jackie, yep. And Michelle and Stan are both correct because if you use the combination formula, it's n factorial over n minus r factorial times r factorial. If you simplify this, 14 take away 9 is 5. You get that. And if you did what Stan said, which is, again, 14c5, that'll be 14 factorial over 14 minus 5 factorial times 5 factorial. And 14 take away 5 is 9. So you get the same denominators. They're just the same factors on the bottom. They're just in a different order. But when you're multiplying, order doesn't matter. Right? So student 3 and 5 have the correct answer. Number 16, we've seen questions like this before. At a meeting, every person shake hands with each other person exactly once. There were 36 handshakes in total. How many were at the meeting? This is saying that NP2 equals 36. Sorry, NC2. Order doesn't matter. And if there was a question like this on a diploma exam now, it would say determine. You have to show your work. So I can expand the n factorial, n bracket n minus 1 bracket n minus 2 factorial over n minus 2 factorial equals, on the right side, you're going to multiply both sides by 2 factorial, which is just 2, which gives us 72 on the right. The n minus 2 factorials cancel. We'll have n squared minus n minus 72 equals 0. N minus 9, n plus 8 are the factors. So n must equal positive 9. You cannot have n being negative. You can't select from a negative number of people. And we can check that. 9C2 should equal 36. And it does. So it does check. How many different 4-letter arrangements are possible using any 2 letters from the word smile and any 2 letters from the word frog? So arrangements means order matters. So these are permutations. You're going to select 2 from the letters of the word smile. There are 5 letters there. Remember, and means to multiply. 2 from the 4 letters in the word frog. So it'll be 5p2, which is 20, times 4p2, which is 12. So this is the first part of this, 240. This is just selecting the letters, though. That's all we've done right now. We've just selected the letters. Then they have to be arranged. We have 4 letters, and they have to be arranged. They could be arranged in 4 factorial ways. So we have to multiply the 240 by 4 factorial to get our final answer. So this is done in 2 parts. The first part is selecting the 4 letters. Then you have to arrange them. 5760 is the answer. Number 18, find the value of A of that expansion if there's 18 terms. Well, we learned that the number of terms is always 1 more than n. N is the power on the binomial. So if there's 18 terms, the power has to be 17. 2a minus 5 has to equal 17. The number of terms is 1 more than n, so n is 1 less than the number of terms. So 2a will equal 22, and a will equal 11. Student made the following statements regarding the expansion of a plus b to the 4th. Student 1 says that there are 5 terms. That is true. Number of terms is always 1 more than the value of n. Statement 2 says that the middle term is 6a squared b squared. Well, let's find the middle term. There are 5 terms, so the middle term will be the third term. Using the general term formula, if we want to find the third term, k has to equal 2. K is always 1 less than the term number. So it'll be 4c2 a to the 4 minus 2 times b to the 2. 4c2 is 6, so it'll be 6a squared b squared. That is the correct middle term. The sum of the leading coefficients is 14. Well, we can get the leading coefficients by using Pascal's triangle. Because n is 4, we want to use the row where the second number is 4. It should also be the row where there are 5 numbers because there are 5 terms, which will be this next row. The second number is 4, which matches n, the power on the a plus b. As well, there are 5 terms. If we add these together, we're going to get 5, 15, 16. The sum of the leading coefficients is not 14, it's 16. For the term 4a cubed b to the m, the value of m has to be 1. Well, remember, every term in the expansion, if you add the powers together, they have to equal n. If the power on a is 3, the power on b must be 1. 3 plus 1 will give you the 4. And the leading coefficient is not 4c1, it's actually 4c0. 4c1 is 4. That's the second leading coefficient, not the first. So the ones that are correct are statements 1, 2, and 4. If you look on the first review package, get it right now, Unit 1, open it up, second page has all that information there. Not the question booklet, but the example booklet. It's all there. Okay. Number 20. You want to determine the simplified form of the sixth term. Remember, k is always 1 less than the term number, so in this case, k would need to be 5. It would be 7c5 a to the 7 minus 5 negative 2b to the power 5. 7c5 is 21. A squared, negative 2 to the 5th is negative 32b to the 5th. And 21 times negative 32 is negative 672. A squared b to the 5th. So there's the sixth term. In the expansion of 3a plus b squared all to the 10th, what is the coefficient of the term containing a to the 4th, b to the 12th? So the power on a has to be 4. If we use the general term formula, we can start to build this. Right, the power on b has to be 12. So that tells us that k would have to be 6. And that also works for the power on a as well. Because when k is 6, 10 minus 6 is 4. And that gives us the right power on a. So we've established that k has to be 6 to make this work. Our coefficient is not just 10c6 because the 3a is raised to the power 4. that's going to affect our coefficient as well. So 10C6 10C6 is 210, and that's multiplied by 3a all to the fourth, which is 81a to the fourth b squared. So it's 210 times 81, which is 17,010. There's the value of that coefficient. In the expansion of that binomial, the constant term can be found using the general term. The list below shows possible values for n, k, x, and y. To find the constant term, the correct values of n, k, x, and y that must be used are numbered respectively, or in other words, in that order. So the constant term will be the term where a is to the power 0. If we use our general term formula to start building this, we know that n is 8. The other thing we would probably do is rewrite the expression so that that second term is a to the negative 1. We know that n is 8, so n, c, k, 2a to the n minus k, 8 minus k, and a to the negative 1 to the power k. The general term formula says that you have NCK, which represents the first term of the binomial. That has to be 2a. So this is what x will go with. X represents the first term of the binomial, which is 2a. X is the third space. That's coded number 6. Y represents the second term of the binomial, which is a to the negative 1, which is represented by code 8. So now we just need to figure out, well, n is 8. Let me see this. Shows the possible values. Yeah, n is 8, which is coded number 5. So the only thing we have left to do now is to figure out what the k value is. And the k value will be the value that gives us a power of 0 on the a's. So if we figure that out, we'll have 8ck, we'll have 2a to the 8 minus k, and the second one will be a to the negative k. If you combine these two together, realizing that the 2 would be raised to the 8 minus k as well as the a, and I didn't write the 8ck because that really has it has no use for us now. All we need to do is find out what the value of k is so that we get a to the power 0 at the end. So I'll only combine those two together by adding the exponents, a to the 8 minus 2k, and that's what must equal 0. We want to find the constant term, which means that it's the a to the power 0 term. The exponent on a has to be 0. So 8 will equal 2k, k now equals 4. which is coded with a 3. So 5368 is the answer. We've seen lots of questions like number 23 before. We want to determine the numerical value of A. So 6ck ax to the 6 minus k negative 1y to the power k has to equal negative 252 xy to the 5th. So by inspection, k has to be 5. That'll give us a power of 1 on the x and a power of 5 on y. K has to be 5. So this will be a to the 1, x to the 1, times negative 1 to the 5, y to the 5. We can divide both sides by x and y to the 5th, and they're gone. 6c5, I think, is 6. Yeah. So you're going to have 6a times negative 1, which will be negative 6a, equals negative 252. So divide both sides by negative 6, and you'll have your a value. Negative 252 divided by negative 6, a equals 42. Yeah.
So on the examination
What?
on the examination specifications,
Right.
they listed the topics here, like relations and functions.
Yep.
Does that mean that exponential on the
Yes, that's all part of relations and functions. Like exponential, they're exponential functions. Logarithmic functions. So that's all part of relations and functions. Yeah. Okay. So next class we'll go through the Unit 4 exam. I've already sent out the review assignment that you must complete prior for doing the reassessment if you choose to. So I'll have that ready for you for the next class as well. And then we'll just have to set a time for you guys to do the reassessment. It can't be during class time. I don't want to take review time away for that. So it'll probably be after school one day, probably. I don't know when else we can do it. Yes. No, they're chosen first. You need to choose 2 letters from each word first. And then once you have the letters selected, then you're going to arrange them. No, you have to choose the letters first, and then you would arrange them. Think of them as a Scrabble thing, right? You'd have to pick out the letters first before you can arrange them. Miriam, you can grab, there's 8 things to pick up over there. Someone already got them for you?